All right, ladies and gentlemen, how are we doing today? Today is February 9th. I can divide with scientific notation. I know what you're thinking. Mr. Stahl, scientific notation is when you multiply and move the decimal. Well, today we are going to divide. Here are your challenge questions. I hope you guys already rocked them and knocked them out of the park. And if you did not, rock them out of the park. Remember, the really important questions, A, B, and C. They show me if you're completely understanding everything right now or if you're a little bit on the confused side. But hopefully, these three questions are review and you're rocking them out of the park. This question, challenge, not as important. That's why these are worth 10. This one's only worth 1. Quick review. We have inside the house is the dividend, and then on the outside is the divisor. And, well, if you have a decimal on the outside, then it's safe. You're good. Everything's fine. But if that decimal's on the outside of the house, if it's on the outside of the house, then you just need to panic, okay? We're going to deal with that tomorrow. Don't panic just yet, because I have a trick that will take care of that decimal being on the outside of the house. But today we're just going to continue to rock when the decimal's on the inside of the house. In fact, we did not get a chance to cover everything yesterday. So I'm going to continue to work on this lesson from yesterday, and we're just going to work on 10 and 12 before we move on to the scientific notation part. So either in your book or on a blank piece of paper, try number 10 out. Pause the video and try number 10. Great practice. All right, let's see how you did. 36 is the divisor. It's going to go into 547 and 2/10. I have had students in the past, they didn't even wait until the problem started. They just went ahead and threw the decimal in their answer so they knew they wouldn't forget. That's fine. So we're going to take 36 and we're going to go into 54 first. How many 36s go into 54? 1. So we want to make sure right on top of the 4, we put a 1. Now we got to figure out what's left over. If you took away one group of 36, well, what's left over? Borrow. 14 minus 6 is 8. 4 minus 3 is 1. And now it's the 7's turn. So how many 36s go into 187? We cannot in our brain count by 36s, so we have to kind of guess. And one thing I always tell students, this is a way to guess. Just move the decimal in once, right? That's a little bit bigger than 3.5. It's 3.6 if you move it in, so it's 4. How many 4s go into 18? Well, 4 times 5 is 20. 4 times 4 is 16, so my guess is 4. So I'm going to check my guess. I'm going to somewhere go 36 times 4 to see how close I am. 24, 14. So it looks like I'm going to have enough left for one more group, right? Because I have more than 40 left. I have 187 to take from, and 36 times 4 is only 144. So now I'm going to go to 36 times 5. Perfect, 180. So 5 groups would be 180, which means there's 7 left over. Can't take down a decimal, make sure the decimal's right there, bring down the 2. Now, I know 5 groups, so it's going to go in 36 times 2 is 72. I know that one, but just to make sure, 36 times 2, well, 6 times 2 is 12. 3 times 2 is 6, plus 1 is 7. So that answer is 72. So I'm going to put my 2 right here. And that's my answer, 15 and 2/10. Okay? 15 and 2/10. And today I'm going to say dinosaur. So if you're doing everything you're supposed to do in the Google Doc after this video, you are going to Say, Mr. Stahl referenced dinosaur. Roar. Dinosaur. All right. Katsu bought 18 pounds of apples for $23.04. What is the price per pound? So we have 2304 divided by 18. How many 18s go into 23? 1, right? What's left over? 5. 5's left over. Before you bring down the 0, you have to make sure your decimal's there. It is. I already did that. 18, 36. Ooh, can I take away 4? Let's see. I'm sorry, 3. Can I take away 3? No, so it's going to have to be 2. I know 18, 2 18s is 36. There's 14 left over. Bring down the 4. If 3 18s is 54, 6 of it would be 108. I'm thinking 7 or 8. Which one do you want to guess, 7 or 8? Let's guess 8 first. So 18 times 8. And remember, you're always allowed to use lattice method here. 8 times 8, 64. 8, 144. Perfect. 8 groups is my 144. And I'm happy. So that answers 1 and 28 hundredths. 1 and 28 hundredths. All right. Now moving on to this next part of the lesson. We are going to talk about scientific notation with division. So here is our scientific notation with division. This is what it looks like. Remember. So a long time ago, scientists came up with this idea how to represent ginormous numbers, right? Especially with working with space. They always have these large numbers that they have to work with, that they decided that scientific notation is the way to go. Because here in 5th grade, we see scientific notation like this: 4.6 times 10 to the 9th power, and we know it's equal to this. When dealing with space, they might be working with an amount that is 4.9 times 10 to the 99th power. You could only imagine how many zeros that is. And if you're using, you'd have to use a whole piece of paper when writing a number like that, whereas with scientific notation, you don't. And we know that when you're multiplying by a power of 10, all you're doing is taking your number, 7, so this is 7, times 10 to the 2nd power. There's an invisible decimal here. You move it over 2 different times. So that represents the number 700. Okay. Just as all these are examples as well. 2.7 times 10 to the 3rd power. You move it over once, you still have to add 2 more zeros. So that's an example of 2,700 and so on and so forth. And you can come all the way down here, 2.7. Move the decimal over once, but you had 6 spots to move, so you still had 5 zeros. There's all your zeros. So there's a way to go back and forth from scientific notation to standard notation. Here, we're learning something new. Now, scientists came up with scientific notation to represent very large numbers, but they also came up with scientific notation to represent very small numbers. Okay, and this is not an example of a very, very small number, but it's an example of scientific notation using division and showing you how numbers get smaller. So right now it's 235 and 85 hundredths, right? And this is like a fraction, 85 out of 100, 85 hundredths. But when you divide it by times 10 to the 3rd power, instead of moving the decimal right, every time you divide, you move it left. So 1st power, 2nd power, 3rd power. So this answer is 0.2358. which is small, which is very small. And we can have our 0 wholes. This is a fraction. It's 10, 100,000, 10,000, 100,000. So what it really is like a fraction. 23,585 hundred thousandths, which is, about a quarter. All right. That's not the one I used. I always do that. So get this big head out of the way. Go over here and erase that ink. Let's go to the next one. All right, so 20, we'll do this one together because it's even. But we're now on page 212. So we'll do this one during our live session. And we'll rock. We'll rock these right now. Okay. So we're still on page 212. So it's divided by 10 means it's moving the decimal into the number. So this turns into 91.63. And I'm going to switch the camera just so we don't spend all my time writing down the number. Because it's hard writing with a mouse, let me tell you. All right. Number 21. We actually use this. Okay. Number 21. We said this moves in once, turns into 91 and 62 hundredths. This moves in twice, right? Because it's divided by 100, which really means divided by 10 to the second power. They're the same thing. So that means it's going to move in 2 spots. 9.162. And then this is going to move in times, it's divided by 10 to the third power, right? Because 1,000 is 10 times 10 times 10. So it's divided by 10 to the third power. 1, 2, 3. Turns into 0.9162. We'll do this one during our live session. Try this one on your own and then unpause it and see how well you did. Okay, divided by 10 to the first power means it's going to move in. So this is 0.78. This is going to move in twice. So it's 1, 2. So it really represents. And you could, I don't care if you don't put the 0 there. We know there's no holes because that's what the decimal's there for. This 0 totally matters because it pushes these over. So it's 78 thousandths instead of 78 hundredths. That 0 matters. And then look at how many zeros we're going to add here. After you go left 1, you still have 2 more spots. So 0.0078. 24 we'll do together. Let's go to 25. 25. 32 divided by 8 equals something. Well, how many 8s make 32? 8. That's 1. And remember, I have a lot of friends out there that are at the point where they really can't count by numbers, right? And they're embarrassed now because you guys are about to go to middle school. Use the numbers. 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 2 8s. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 4 8s. So 8 times what is 32? 4, right? And they call this like a pyramid. I'm working on this with my son right now. They have pyramids for adding and subtracting and also multiplying and dividing. So 32 is the top of the pyramid, and it's an 8 and a 4 that make it. If the 4 is missing, you can do 32 divided by 8 to find the 4. If the 8's missing, you can do 32 divided by 4 to find the 8. And if the 32 is missing, you multiply those together to find the top, right? So they call it a math mountain, and they're a family, and you could find, as long as two of the pieces are there, you can find the last piece. So let's move over to 27. So it says 0.32 divided by 8. Ooh, so let's go like this. 0.32 divided by 8. This helps me realize what's going on. It does not go into that. You have your decimal, and then how many times does it go into 3? It doesn't. How many times does it go into 32? We already said 4. So that answer is 0.04. And 0.04 is like 4 pennies. If you have 8 groups of 4 pennies, would that be 32 pennies? Yeah, that sounds right. So 8 times what is 0.32? Well, we just did that math. So what they're doing now is they're trying to see how well we understand the math. Okay, so they're testing, how well do you understand it? If you're getting this, then you really understand it. If you don't get this, don't get too frustrated. And then, you know what? That's all we'll do right now. We'll do this live if we have time. We'll do this live if we have time. And remember that animal that I told you, because that is going to be on your Google Doc today. Good job watching, and I'll see you during our live session at 10:30.